All right, here we are with the third lesson of this week. It's called Ratios in Right Triangles. This lesson is a little weird, I'm not gonna lie. So I'm gonna try and explain to you kind of what you're supposed to get out of this. There is a lot of review in here. We start with some radicals review. We did that 2 days ago. So if you want some help with that, go watch those videos. But you should definitely do these problems just to make sure you remember how. Now, another thing that we're going to look at is we're going to connect this kind of to our last unit, similarity, today. So it says a triangle ABC is similar to triangle DEF. What 6 parts correspond to each other? All right. So we have 3 sides and 3 angles, and let's just do the angles first. We know that angle D has to be congruent to angle A has to be congruent to angle D. We know angle C has to be congruent to angle F, and we know that angle B has to be congruent to angle D. This is because when triangles are similar, they have all the angles the same. The other thing that we have is that we have sides that match up together, right? So AC, that is one side of our triangle, and we know that is proportional to DF, right? Proportional, remember, means that, well, let's just fill them all in before we talk about that. AB corresponds with DE, and BC corresponds with EF. So really all these sides are proportional because they all have the same scale factor between them, right? So this could be a scale factor of 2. That means every side is getting twice as big, or it could be a scale factor of 3 or whatever. But we know that they're all the same, right? So whatever DF is, whatever you multiply by to get to AC, that'll be the same thing that you multiply DE by to get to AB, and EF by that you get to BC, okay? So that's kind of similarity. We also have some Pythagorean theorem review here. You guys should be able to do 5 and 6 below. If not, make sure you check out yesterday's video. But the third problem here, notice it says if you can, right? Can we do the Pythagorean theorem here? Well, we have 3, we have a completely missing side over here, and we have Z. If we tried to do the Pythagorean theorem here, we'd have 2 missing sides. So the Pythagorean theorem actually only works if you know 2 side lengths, right? If you only know 1 side length, the Pythagorean theorem doesn't work. Notice here that we actually have H is equal to 50 degrees. And this necessitates a different kind of strategy, and that's kind of what we're going to start working on. So number 8, what could Z possibly be? It just wants you to make a guess, right? Like, could Z be 1? I don't know, that's for you to decide. Could Z be 5? Is that a reasonable number? Could Z be 100? Is that a reasonable number? That's kind of what it's talking about. Same thing for 9, what values that Z could not reasonably be. So you're not doing any math here. You're just kind of making your best estimate on what you think Z could be. All right, now you get to this part where it's talking about making a ramp, okay? So according to the Americans with Disabilities Act, ramp guidelines, this is a real thing, you can look it up, okay? Ramps can only have a maximum slope of 1 to 12, which is 4.8 degrees. So this means that if you have a ramp, the maximum slope, so remember, slope is like how fast is this line going up, right? This right here, this would be a like really small slope, because I'm going up really slow, whereas this would be a really big slope because I'm going up really fast. So the maximum slope that you can have is 4.8 degrees. And that corresponds to 1 over 12. 1 over 12, basically a proportion between those 2 sides, okay? So any ramp has to stay at this value or be underneath it, okay? So up here, they talk about the door to the school has 4 steps that are each 7 inches tall. Okay. So if we have 4 steps and each step is 7 inches tall, how many inches is that in total? Well, 4 times 7 is 28. Okay. So that means that the door to the school is 28 inches off the ground, right? You can imagine that's the door. So if we have a ramp, right, we need it to be able to go up 28 inches. That means we need to figure out what this is going to be down here, okay? Now, we know that we have to stay within this guideline of 1 to 12, right? So hopefully you can kind of see how this is related to similar triangles, right? It's that we have all the same angles, right? We have 4.8 and 4.8. We have 90 and 90. Oops. And then we also know that whatever is up here and whatever is up here are also going to be the same. So we have similar triangles here, right? So we're basically taking this similar triangle and scaling it up to make this, right? So what are we multiplying by? Well, over here we have 1 and over here we have 28. So that means we are multiplying by 28, right? That's our scale factor. So in order to figure out, what is this going to be right here, we need to take 12 and also multiply that by 28. And that is 336 inches, okay? So that's how long basically your ramp would need to be. Hopefully that made sense. If not, rewind it, I guess. But really, basically what you need to do is just whatever number this is, right? Because originally that was 1, so we multiplied it by 28. And originally this was 12, so we multiply that by 28, okay? So this is the answer down here, 336 inches. And basically, they just want you to do that a couple more times, right? So you can see that here we have our guidelines up here of 1 to 12. We look over here, we see we have the 4.8 degrees all the time, and they want you to find the missing side. So here they want you to find, what will the height be if this is 6, right? If the length is 6, then how high is the ramp? Here we have a height of 4, so what is the length? Here we have a length of 36, so what is the height? And here we have a height of 2.5, so what is the length? All right, and you're just gonna, again, use similar triangles to figure that out. And that is it. That's everything for this. So when you're done, you can go ahead and submit that, and have a great day.